I'm going to add yesterday's notes where we started the logs. And so we were converting from log form to exponential form. Okay, we talked about that. And that skill is going to come into play. And so, there's a reason that we're not going to use it much today, but we're going to keep practicing it because when we start to use it, we use it a lot. Okay, but today, what we're going to do is take some notes on exponential growth and decay. So you guys probably should write this down. So you may have heard the term and probably have, some things that grow exponentially. That means it grows very, very fast. Okay, or decay exponentially for that matter means they go the other way very, very fast. And so when we talk about exponential growth and decay, there's one big equation that you're going to want to get familiar with. And that is, and there's a couple of small variants of this, but I'm going to write it as y equals a times b to the x. And of course, following the order of operations, if we plug in something, you do the b to the x first and then multiply by a, and we'll get to all that stuff. Okay, we would do the exponents before multiplication. But let me explain what each of those letters stands for. In this case, the y is your final amount. And A is your initial amount, how much you start with. B is, it's your rate, but it's kind of, actually I should write it as B is 1 either plus or minus your rate. So if it's growing, it's 1 plus your rate, and if it's decaying, it's 1 minus your rate. And X is oftentimes time, and will be in the ones that we do for now. All right, so here's something that would be like an example of some exponential growth, like population grows exponentially, or sometimes can decay exponentially. But let's say, for example, and this is going to be a word problem, we're going to write this down here. So a town has a population of 18,000. So a town has a population of 18,000 and grows at 3% annually. Or let me say 3% per year. Okay. What is the population in, let's say, 6 years? All right, so a town has a population of 18,000 and grows at 3% per year. What is the population in 6 years? So we're using our formula from up here. We want to know what's our final amount of people with an initial amount or initial population of 18,000. That's our A. Our B is it's growing at 3%. So that is 1 plus, now as a percent, that's 0.03. Okay, in fact, let me scratch that. I'm just gonna, 1 plus 0.03 is 1.03. So let's be mathematicians here, right? So that is 1.03. And then my time is 6 years. And that's it. From there, we're just gonna plug it into our calculator. Okay, but looking at this, I want you guys to be able to look at this and say, all right, this is our initial amount of 18,000. And this tells me that we're growing at 3% because it's 1 plus 0.03. And then this means for 6 years. So now I'm going to take that and I'm going to plug it into my calculator. You guys should do the same just to get the practice of hitting the buttons correctly. So I've got 18,000. And I'm going to do times 1.03 to the 6th power, hit enter, and I get 21,492.9. Well, we're talking people here, right? So instead of 0.9, you're not going to have 0.9 people. Let's call that 21,493. So our population would be 24,493. Well, 21,000. Not 24,000. 21,493. Sorry about that. Check my calculator again. All right, let's do another one. All right, next example. Let's say a car is purchased for $21,800. Must be a nice car. So a car is purchased for $21,800. And depreciates depreciates means it goes down in value, which almost all cars do. Almost all cars. There are some very few exceptions that may appreciate, but almost all of them depreciate and depreciate quickly, by the way. So they depreciate. So this one car was for $21,800 and depreciates at 9% per year. Unfortunately, it's probably kind of average. How much is it worth in 8 years? So this is now depreciating. So our equation, we have y equals, we want to know how much, so the final amount. Our initial amount is 21,800. And now this is going to be 1 minus 0.09 because it's depreciating, it's going down. Okay, better known as 0.91. So I'm going to write this. We are all mathematicians here. I'm going to write that as 0.91, which really kind of means it has 91% of its value, and for 8 years. And so I will go back to my calculator. And so I'm going to do 21,800 times 0.91 to the 8th power. and I get this. Now, remember, this is money. So it's now worth $10,251.50. Okay, so don't write 0.5, write it as money. All right, so that was $10,251.50. So look at that. I mean, less than half of its value, right?
Are we supposed to round up, like, because it's like 50 cents, but it's like a 5, so could it be 51, or like how does it work?
Yeah, so you would not round up in this case if it was because it was 10 to 5 1.5. If it was 0.576, you would then round that up to 58 cents. Okay, but in this case we do not round that up because there weren't enough digits there, because that was just 0.5.
Oh, I think it's because like I think I have a different setting on my calculator. So I got like 5s, like after the decimal, I got 505102.
Oh, you did?
Yeah.
Let me take a look here. I'm glad you brought that up. Perhaps in that case, then it would. So let me take a look here. Let's go to my settings and take a look here.
Oh, Mr. Connor, how did you get the 0.91?
Yeah, so what I did was I took, Sam, let me come back to yours in just a second, because I just did the same thing on my calculator, and you are absolutely correct. We should round that up. So it is 10,251 and then 0.51 because it's 0.505. So thank you very much for catching that. That was a setting on my calculator that was set incorrectly. All right, so that is going to be 51 cents. Now, Sam, I think your question was, how did I get this? So remember, this was depreciating. And so in there, this part right here, that B, is 1 minus the rate. And because it was depreciating at 9%, I did 1 minus 0.09. And 1 minus 0.09 is 0.91. That's where that came from.
Can you show the formulas like at the top? Because I didn't get those.
Yep. There's the whole thing right there. Is that big enough? Can you see that?
Yeah, I'm just going to take a screenshot.
Yeah, absolutely. All right. And so again, I would like you guys to be able to look at this and say, you know, just quickly going off the cuff, this is appreciating and this is depreciating. Or the first one, this one is an exponential growth and this is an exponential decay. And it really has to do with if it's 1 plus something or 1 minus something. All right. Any questions, guys? Any other questions? Those were good ones.